example 4 on page 543, solve the equation x equals to square root of x plus 7 plus 5. Alright, to solve this equation means we need to solve for x. Now this x inside the radical, you cannot combine with this x right here. So your goal is to remove this radical using the principle of powers. Okay? So my goal is to isolate the square root of this radical right here alone so that I can use the principle of powers that say if the equation A equal B is true, okay, then you can take A raised to the n power equal B to the n power. The left hand side still equal the right hand side. Okay? N is some natural number. Alright, solution. X equal to square root of x plus 7 plus 5. For this equation, first thing I want to do is to isolate this square root alone. So that means I need to remove this constant phi. Subtract phi on both sides. X minus phi equal to square root of x plus 7. Phi subtract phi is 0. Okay. Now, as you see, this square root now it stands alone, right? That means we can apply the principle of power to remove this radical. Alright, we can do that by square on both sides. The reason we square it or raise to the second power because we have square root, and for square root, the index or k root is 2. Okay, so I'm going to square on both sides. Okay, after I square it, this term right here will turn to be x plus 7. That means I remove the radical. That's the reason why I raise both sides to the second power. Now for this left hand side, we learned the squaring binomial, which is a minus b, when you square it, is equal to a squared minus 2 times a times b plus b squared. I'm going to use this formula for the left hand side. So a is x. So we have a squared is x squared minus 2's ab. Now we learned all these before, so nothing new. Twice ab, so twice of x times 5, and plus b squared, b is 5, so 5 squared. Okay? Simplify, we have x squared minus 2 times 5 is 10, 10x, and then plus 5 squared, 25, equal to x plus 7. And you see, after you square this, we have an equation without the radical. Okay? And then we simplify, we get this. Now, to solve the equation, we will use the principle of 0. That means we'll move all term look like on the right hand side for this k to the left so that we have one side equal to 0. So to have one side equal to 0, using the principle of 0, I will remove all the two terms, okay, on the right hand side. That means I will subtract x and subtract 7, and I'll do it to both sides. And then simplify, we have x squared negative 10x subtract x is negative 11x. 25 subtract 7 is 18, positive 18. And then this is 0. And this is 0. 0 plus 0 is 0. Now, you have a trinomial, x squared minus 11x plus 18. We learned how to factor trinomial. So we need to factor this trinomial. X squared minus 11x plus 18 You can use AC methods, you can use for methods. This time I'm going to use for methods. So x squared, we have x times x is x squared. This 18 right here can be 2 times 9, can be 1 times 18, okay, or 3 times 6. That's all about we can factor out. These are the cases. Now, because c is positive, you know that all the factor of c will have the same sign as b, which is negative 11. So that means all the sign of these factors are going to be negative. Same sign as b. Okay? And it looks like negative 2 and negative 9 is okay because when you take the sum, you get negative 11. So I'm going to use negative 2, negative 9 here first and test to see what happened using the for method. X times, so again, x times x is x squared. We got that. And negative 2 times negative 9 is positive 18. So we got this term. The only term we need to check is this middle term. We do that by multiply the two terms. D2, negative 2 times x is negative 2x. And then x times negative 9 is negative 9x. And then you're adding these two, negative 2x plus negative 9x. Simplify, you get negative 2x, negative 9x, which equal to negative 11x, which is the middle term. So you know that these two factors are factors of the trinomial x squared minus 11x plus 18. So I'm going to replace these two factors for this trinomial, which is here. So I have x minus 2 times x minus 9 equal to 0. Alright, by the principle of 0, we have x minus 2 equal to 0, or this second factor, x minus 9 equal to 0. Okay, we can simplify this and solve for x by adding 2 on both sides. We'll have x negative 2 plus 2 is 0, so we don't have to write that. 0 plus 2 is 2. And then plus 9 on both sides, we have x. Negative 9 plus 9 is 0. So x plus 0 is x. 0 plus 9 is 9. So look like we have two possible solutions. Again, we need to double check if the two solutions are truly solutions to this radical equation. Remember, when you square both sides right here using the principal power, is always strongly recommended that you check the solution, because sometimes what you got are not actually the solution. So I'm going to check the two solutions. X equal to 2. Checking this, I will substitute 2 to every x in the equation. So the equation is x plus equal square root of x plus 7 plus 5. Okay. Substituting these two here for x, square root of 2 plus 7 plus 5. So I just replace 2 here for every x. And then once I substitute the x equal to 2, I don't know if the left hand side still equal the right hand side, so I put a question mark. 2 here equal to 2 plus 7 is 9 plus 5. Okay. Now, by now I hope you can see that 9 you can factor out to be 3 squared plus 5. And then not only that, because this is square root, index 2, matched with the exponent of 3 squared, that means you can move this factor 3 outside the radical. In a way, simplify it to 3 plus 5. Okay, question mark. The question is to see if the right hand side is still equal to the left hand side too. So 3 plus 5 is 8. So guess what? 2 equal 8, which is false, right? This is a false statement. That's why x equal 2 is not a solution. Okay? Because having this solution, it will use a for statement. Let's check the solution, x equal to 9. So we have the equation x equal to square root of x plus 7 plus 5. Okay, the original equation, x equal to square root of x plus 7 plus 5. Replacing 9 for x, we have 9 equal to square root of 9 plus 7 plus 5. Again, you're just substituting the x. You don't know if it's true or not, so you put a question mark to verify later on either the left hand side equal to the right hand side or not. 9 equal, so 9 plus 7 is 16 plus 5. 16 is 4 squared, okay, plus 5, and then 9, and then 4 squared. Again, this is index 2 matched with the exponent 2 here. That means you can factor this 4 outside the radical, or simplify this to 4 plus 5, question mark, 9 equal to 4 plus 5 is 9. Again, 9 equal 9, which is true. That means x equal to 9 is the solution to this equation. So x equal 9 is the solution. Okay, so again, in the quiz or the final exams, you will see that I would put the solution is 9. So for this example, right, I will put the solution is 9 because there's only one solution. This is not the solution for the equation. So make sure you familiarize with the way how to solve the problem. Make sure you check it when you have either one or two solution. Make sure you check it. Make sure that is the correct answer.